Good morning, everyone. Today we'll be learning about application of Newton's laws on the human body. Before going to the Newton's law, first let us learn about equilibrium. A balanced state or equilibrium is defined as a state where either a body is in complete rest or in a uniform dynamic motion without alteration of its position. Newton's first law, or also called as law of inertia, identifies whether the body is in the equilibrium or not. Let it be static or dynamic equilibrium. Thus, law of inertia states that object remains in static position or uniform dynamic position unless acted upon by an externally developed resistive force. I mean it, externally developed resistive force. So this is an example of law of inertia on human. Look at the video. I'll repeat it again. Look at the video. The boy is standing in a static position. Immediately in a moving train, he steps out. He couldn't maintain his balance or he couldn't maintain his equilibrium. Thus, the law of inertia classifies the bodily adapted posture into two types, static and dynamic. When there is no visible movement, it means static. When there is definitely a visible movement, that means it is in a dynamic posture. Coming to the second law, Newton's law of acceleration. This is the second law of Newton, which states that the linear or angular acceleration of an object is directly proportional to the net force moving it and inversely proportional to the mass of the object, considering F is equal to ma. I hope everyone knows the formula F is equal to ma. When we talk about the same formula application on the human body, we cannot apply the exact same formula because an object has a mass whereas human body has weight. Substituting that, weight is equal to mass into gravity. Look at the video. A person is trying to push another person, but because of the internal force, more amount of internal force in the person B, she threw him out into the water. If a person wants to move his or her body, either running or walking or pushing in our condition, the acceleration of the body depends on the force exerted by the muscle required to move the body and the weight. Substituting F is equal to ma becomes F is equal to weight into gravity into the acceleration. Coming down to Newton's third law, law of equal and opposite reaction. So every action has equal and opposite reaction. You can see in the video that a person tries to, put the ball in the basket, but because the force is less, the ball is bouncing back. The same example can be given for antagonist and ergonist, where when ergonist contracts, antagonist relaxes, and when antagonist contracts, ergonist relaxes. This is the human bodily example for Newton's third law. So thank you so much for patient listening. We'll meet you in the next video on force vectors, application of force vectors in human body. Thank you.